Today's demo is going to focus on mitigating of the latest Log4j vulnerability using Big IP, and specifically focusing on the emphasis of application security and the component ASM. Today's demo is also going to specifically focus around how to enable these policies within Kubernetes. So the focus here is to use Big IP to front end a Kubernetes cluster and protect the Kubernetes cluster from any type of Log4j vulnerability or a Log4j attack. Within this demo, I have my distinguished colleague, Brandon, a solution architect with F5. And Brandon's going to talk a little bit about the importance of protecting your Kubernetes cluster from this Log4j attack. Brandon, thank you so much for joining me. Why don't you just give us a little bit of a background before we kind of get into this demo about the Log4j vulnerability and how Big IP can help?
Yeah, thanks, Mark. So there's primarily three vulnerabilities that have been identified recently in Log4j. It's a near ubiquitous logging tool in Java environments. And since December 9th, 3 unique vulnerabilities have been disclosed in the logging framework. The most serious of which is a critical RCE, or remote command execution vulnerability, that the Apache Foundation disclosed. The flaw exists in a Java naming and directory interface lookup feature that is enabled by default in versions of Log4j 2.0 beta 9 to Log4j 2.141. The attackers can exploit the feature to take complete remote control system of vulnerable systems, many of which are, of course, internet-facing. The Big IP itself being a proxy, has multiple different ways of mitigating. We have published iRules and that are able to mitigate the attack. But more importantly, we have our advanced web application firewall that allows us to publish and update signatures to mitigate attacks against the backend infrastructure.
So Brandon, let me take a look. And so if we take a look at our Big IP, we can make sure that our Big IP has the latest signature. So let's go and take a look at these signatures that we have on the Big IP here. It's just pulling down an update here just to take a look to see what has. And so this will show us the signatures. And so as you can see right here, I'm just going to make this a little bit bigger for our users. So Brandon, earlier on today with the advanced web application security, I pulled in the latest signatures. And so Big IP actually went out to the F5 cloud, pulled down these signatures. And then what I'm going to do is I'm going to associate these signatures as part of a profile, correct, to my ingress, that is ingressing traffic to the Big IP cluster through the Big IP. And so if you want to talk a little bit about these signatures so that our customers kind of know where to get these signatures from, then I'll talk a little bit about how we associate the signatures to the WAF policy and then associate that to an ingress, because this is what's really important, is that this Big IP running Advanced WAF is front-ending or acting as an edge device or an application firewall for our Kubernetes cluster.
Right, and so the signatures themselves are created by our product development and CERT based on the research that is widely available on the internet, as well as our own internal research. The signatures get updated on a regular basis. In this case, they were updated as soon as we identified solutions for Log4j and some of the attacks vectors that were being exploited. And then they were recently updated a couple days later as new vectors were identified. And so our CERT is regularly scouring the internet for new updates and keeping on top of recent security vulnerabilities, and as they are collected, new signature sets are published and updated.
So as you can see, I've currently installed the latest set of signatures, and if I go to my security go to my Advanced WAF, I have the following WAF policy, and this is a WAF policy that is going to be blocking. As you can see, that policy is currently not associated to any virtual server, right? So right now the policy needs to be associated to a virtual server, and as you can see, there are no virtual servers associated to my big IP. So Brandon, let's talk a little bit about the importance potentially of a Kubernetes environment, right? Because if we think of DevOps, the potential DevOps administrator is maybe creating or has created these applications or these pods, but these pods might be vulnerable since they could be running something like Apache Tomcat, or they could be running a vanilla Apache application that is not necessarily patched inside Kubernetes, or the pod is actually vulnerable. And so therefore, it's really important that we firewall the actual cluster, the entire Kubernetes cluster, for that, specifically for potentially for all URLs coming into that cluster, or for specific applications.
Yeah, it's incredibly important because we've gone from an era of data center sprawl to cloud sprawl, and within a Kubernetes application, there could be hundreds of different components that all could be vulnerable, and it can take a lot of time to go through and audit all of the different applications that are running within, or subsets of application microservices that are running within that environment. And therefore, at least mitigating those kind of attacks at the ingress protects you from rogue actors out on the internet, from zero-day type updates to long-term vulnerabilities like SQL injections and other common input validation issues.
So Brandon, what we're going to do is we actually have within Kubernetes, we actually have the capabilities to use custom resource definitions. What's really cool about a custom resource definition is that we can specify the spec that's important to the big IP. So it's abstracting big IP objects into something that's a little bit more DevOps friendly. So more of a DevOps terminology, DevOps language that the Kubernetes administrator is more familiar with. And the Kubernetes administrator doesn't necessarily have to worry too much about the big IP configuration. The configuration of the WAF policy, Brandon, in your experience, who would configure the advanced WAF to make sure that the policy is there, and then work with the DevOps or create a, if you want to call it a SecOps or a security profile so that it would get picked up? And as you can see here, you can see that there is a policy name called Policy My Site, and that's another CRD that associates all of those security policies, or at least the security policy that is going to enable the application, the advanced WAF, to this virtual.
Yeah, so in a lot of cases, you have a higher overarching security department that says, thou shalt mitigate against certain high-level attacks. And that comes down from your SecOps type teams. The Advanced WAF has the flexibility to leverage also what's called a parent and child policy relationship. And that gives you the ability to delegate more granular control to a DevOps type team. But the overarching parent policy can be defined to protect, especially against high-level vulnerabilities like the Log4j exploit.
And that's really cool, Brandon, because in this case, as you can see, we're using the Policy CRD framework as that potential parent policy. And so as long as this Policy CRD is added to the virtual server CRD, then this profile and this specific policies will be associated. So this would provide a custom HTTP header. This would provide all login of all requests. And in this specific instance, the WAF policy itself. What's really cool, this is a brand new feature that is shipping in a couple days with CIS 2.7, the introduction of the Policy CRD. What you can also do here within the Policy CRD is if you don't want to, or if you don't have Advanced WAF, you could potentially also use the I rule, right? And so the I rule is another mitigation. Brandon, keep me correct here. That you can also mitigate the Log4j with utilizing the specific I rule that is available on BigIP.
Yes, I rules are a scripting language that allows you to modify the data plane traffic as it's traversing through the big IP. So it gives us the ability to respond to zero-day vulnerabilities with some custom code, such as we've published in the iRule. One of the challenges we often face, though, is that a lot of customers will have lots of iRules to maybe do some host routing within a Kubernetes environment or something like that. And iRules can get kind of sticky and not be maintained for their lifetime. And once the backend systems are patched, they may not necessarily be needed, and the maintenance isn't always there. So it's always good to have a WAF policy that allows you to work with the latest security signatures instead of completely relying on an iRule.
And that makes sense here. So this new feature that is coming in CIS 2.7 enables the security administrator to configure the WAF policy, and then the Kubernetes administrator to reference that WAF policy in a policy CRD. So let's go and enable these three CRDs. I'm going to enable the CRD for my app, and it's going to do a couple things. It's going to reference that policy, the policy CRD. It's also going to reference to make sure that we do an end-to-end TLS encryption. So we're going to do edge encrypt, take a look at the specific URI, make sure that we provide clear text to WAF, and then when WAF is completed, we will re-encrypt the packet and re-encrypt that, and then send that to the Kubernetes pod. Our backend is really just an F5 demo. It's just a service. It's a pod service. And so that pod service is potentially vulnerable to this Log4j, and that's one of the reasons why we associate in this policy. So in Kubernetes, what I'm going to do is I'm going to create these three policies, and as you can see right there, there's the policy CRD, there's the transport server to make sure that we have the end-to-end encryption, and then of course there's the virtual server CRD, which is the public IP on BigIP on the BigIP. So let's go and take a look at the BigIP virtual. I'm going to change into the Kubernetes, and as you can see right there, there is the virtual IP. And let's take a look at the security policies. And so, Brandon, so what is this? So what does this show? What does this tell me right here?
So this is the security overview for that particular virtual server that you deployed. Within that, it shows that there is an application security policy enabled and what specific policy is being referenced by that. And then lastly, you have your logging profile, which is going to log all of the requests that come through that virtual server.
Excellent. So if we go down to the application security, at this point, we can actually see that this policy is blocking and it's associated to that virtual. And so let's go ahead and connect to this application and potentially maybe do a, So what does that show me there? It basically shows me that there was an error message when I tried to simply just send a very simple signature, just a simple signature that is part of all the signatures that I'm protecting. So Brandon, what does this show me?
Yeah, so when a request is blocked by the web application firewall, it includes an announcement that is also customizable, but this is the generic announcement that says your request was rejected, and there is a support ID, so you can use that number to reference when working with your support engineers or your security engineers to figure out exactly why the request was blocked.
And so I can actually take a look at the event log, and I can actually see here in the event log what actually was blocked. And as you can see, there was the event log. So this would be the same if somebody was generating a log4j attack. We would see the same type of block, and then we would see the message in the application request event logs within the security section here.
Sure.
Excellent. So Brandon, so now that the big IP is configured and is protected in the Kubernetes cluster, what I've gone and done here is I've cleared all the requests out of the log. So what I would like to do at this point is I would like for you to go and do your magic and go ahead and attack my Kubernetes cluster using whatever special tools that you have. So why don't you go ahead and tell us a little bit about what you're doing. I wanted to kind of hide this because you're using your tools in the background. And then what we're going to do is we're going to take a look to make sure on the security event logs that this attacks actually get blocked. Go ahead.
Yeah, thanks, Mark. Yeah, I'm going to be using some readily available with minimal searching examples of Log4j exploit code that we can test and validate that the WAF is actually blocking those requests. Well, identifying them first, of course, blocking them. So I'm not going to actually publish what we're doing because it's all available, but I don't like pointing people to exploit code. And so I just sent my first simple, well-known attack, and you should be able to catch that. Great.
Excellent. So, okay, so this was blocked. And so what are we seeing right here? This was at my site. This was at my app.f5 demo, which is what's vulnerable. And I can see the forwarded full there. And so what were you doing here?
Yeah, so I was just sending a modified header that included one of the known exploit signatures, well, that matches one of the signatures specifically to the website that you have stood up and protected with ASM. The other thing that you're seeing in here is, of course, the source IP address, source port, a lot more of this information, such as geolocation, and that would be built out if we were working on an internal network. And then most importantly, you see the enforcement action is set to block and the violation rating. So one of the important things people are always concerned about is, oh, is this attack actually something I should care about? Is it a threat? Was it a false positive? Right? We know with a high certainty that this was a threatening attack.
Excellent. And so that's actually good to see that the Advanced WAF policy that was actually configured in Kubernetes is actually blocking these attacks from coming into the Kubernetes cluster. This is really good to see. So are you going to generate some more of these Log4j attacks?
Oh, I already have.
So let me go ahead and take a look at the refresh the screen. And so, okay. So, let's would you like me to take a look at this top one? Okay, so look at this one. Oh, so you can actually see these right here. So this is the next one. Would you like me to look at this one, or would you want to see some other ones right here?
No, I think that's pretty representative of what's being sent, and we don't really need to dig too much into it. One of the other nice things is that you can identify that the WAF will look at attempts to obfuscate the code, and the WAF will actually work to deobfuscate it and protect against those attacks as well. I think you've got the resources there, which are the important thing for F5 customers, how to mitigate, as well as the knowledge base that covers all of the F5 products and their versions and signature sets that need to be updated for mitigating the attacks.
Brandon, thank you so much for taking the time. Really appreciate it.
Thanks, Mark.